Okay, Math at Work 10. We are starting a new unit now. We've finished our work on all of our area and surface area measurements. And what we're getting into now is basically a unit, basically it's trigonometry. Okay, so what we're going to start with today is looking at right triangles. Right, there's going to be a huge focus on triangles. We're going to look at right triangles and the Pythagorean Theorem. All right, that's what we're going to be looking at for this lesson, and then more applications of Pythagorean Theorem next lesson. Okay. All right. So, like I said, we're working with right triangles today and looking at the Pythagorean Theorem, which might be familiar to some of you, might not. I'm not sure kind of where you're at with this, but we're going to go over it anyway. Okay. If you're thinking about textbooks, so we've done chapters 1, 2, and 3 at this point. We're skipping over 4 and 5 right now just based on priority of what needs to get done before kind of we wrap up with our of course, we're trying to prioritize stuff, and this would be one of the bigger priorities than chapter 4 and 5, so we're looking at chapter 6 right now. Okay, so like I said, in this next unit, we're going to be exploring properties of triangles, specifically right-angle triangles, and in this lesson, we're going to look at the main relationship between the sides of a right-angle triangle, use the Pythagorean Theorem. Okay, so before we begin, we'll just really talk about a couple key things that we need to, address and know as we go through this course, and as you go through any math course really when it comes to triangles. So of course you probably all remember that every triangle has 3 sides and 3 angles. Those angles can also be called vertices. Right, the vertex is the point of the triangle. We also need to know that the sum of the 3 angles inside a triangle is 180 degrees, which means if you add up all of the angles, all the 3 angles inside the triangle, that will always add up to 180 degrees. We're specifically going to be looking at right triangles or right angle triangles, right? Those words are interchangeable, okay? And with a right angle triangle, one of the angles is always a 90-degree angle, okay? So that's a key thing that we need to know going forward in this lesson. All right, so when it comes to labeling triangles, right, there's actually a standard and correct way of how we correctly label a triangle, okay? And the reason you want to do this mathematically is just so there's consistency with how everyone does it, so that it's just, the same across the board, and it's easy to understand how people are doing things. You don't have to figure out, well, how did this person decide to label, how did this person decide to label? It's all just the same. Okay, so with labeling triangles, what you do is you label each vertex of the triangle with a capital letter, right? So you see here it's A, B, C, right? And these would be the angles. So this angle in here, that's angle A. This angle here, that's angle B. This angle here, that's angle C. Okay. You then label the lengths using the same letters, A, B, and C, but you use lower cases for the lengths, right, capital letters for the angles, and the length that corresponds to the same letter is directly across, right? So here's angle A, so side length A. If you come across the triangle, that's side length A. Right, if that's angle B here, go across the triangle, then that's side length B, right? And here's angle C, go across the triangle, and there's side length C there, okay? So you get the same letters, capitals meaning the angles, lowercase being the side lengths, okay? All right, the other way you can label side lengths as well is just by using the vertices, right, on the ends, right? So like this side length here, right, could also be called just side length AC, because it's the line that connects point A to point C. And this side length here could be called BC, right, because it's the side length that connects point B to point C, right? And again here, this could be either called AB or BA, right, because it's the side length that connects point A to point B, okay? If we're naming a triangle, we name the triangle based on its 3 letters, right, that we've used to label the vertices. It doesn't always have to be ABC. Right, any 3 letters will do. They just have to be 3 different letters. They can't be any of the same letters. Okay. So for instance, this one here, this would be called triangle ABC because we've used the letters ABC. If we have this right triangle down here, you see the letters used were RST. Okay. So this would be just called triangle RST, and you'll see this in your textbooks or in worksheets a lot, where you'll see this just a triangle symbol and then the 3 letters, right, which indicates that it's the triangle connecting point R to point S to point T, okay? Again, if you're kind of looking at that notation there, right, if this one was labeled triangle RST, then this side length here down along the bottom, that would be considered side length R, and it'd be a lowercase r down here, right? This side length here, right, is directly across from the angle t, so this would be a lowercase t here, and then this side length here, the height over here, would be side length s because it's directly across from that angle s. Okay, so that's how we just label triangles. Now, if we focus mainly on right triangles, which is the focus of our lesson, okay, we have to have that, a right triangle has to have one of its angles to be a right angle, right, 90 degrees, and you can note that on a diagram by a little square in one of the angles, right? So if it's a right angle, it will typically show this little square in the corner to really drive home the point that yes, this is in fact a right angle, okay? So that shows it there, okay? Now, when we talk about the other parts of a right angle, right? So yes, you've got your right angle, and then you've got the rest of the triangle. You've got three sides of the triangle, and in a right angle triangle, side lengths are either called the leg or the hypotenuse. So the hypotenuse is always, 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 always the longest side of a triangle, of a right triangle, I should say, and it's always directly across from the right angle. So whichever angle is the right angle in a right triangle, the hypotenuse is always the side length that corresponds to that, right? The one that's directly across. So if right angle is t, then the hypotenuse would be lowercase t. If the right angle was at b, then directly across with side length lowercase b, that would be the hypotenuse as well. Okay, so the hypotenuse is always directly across from the right angle. The other two sides are both considered legs. Okay, so there's the legs of the triangle, and then there's the hypotenuse. Okay, so again, you see that diagram here, right? There was the right angle, go directly across the triangle. That's the hypotenuse, and the other two are just the legs. And it doesn't matter, they're interchangeable, right? It's not like there's always like, oh, this is leg 1 and this one's leg 2. It's just there's two legs. They can be interchanged in terms of which value goes where, okay? Okay, when it comes to estimating the hypotenuse, like I just mentioned, the hypotenuse is always the longest side of a triangle, and just in general, the shortest distance between any 2 points is always going to be a straight line, right? So, I mean, we don't always have that option. We have to follow roads or trails, and that leads us kind of around things, but, you know, if we just go straight from point A to point B, that would always be the shortest distance, okay? So if you consider a rectangle, the shortest distance to get from one corner to the opposite corner is cutting straight through the middle, right? And that creates a triangle. So you can see that in this diagram down here, right? So you can kind of consider this soccer field, right? And if you were standing at this corner of the field and you wanted to get to this corner of the field, well, the shortest possible way to do that is to cut directly across the field. And when you do that, right, because this was a rectangular shape, you do have a right angle in here, right? So you create this right angle triangle, and that path that you just walked would be considered the hypotenuse, okay? So if we're thinking about estimating, yes, we know it's the longest of the three sides. So we know that it would have to be bigger than 60. It would have to be bigger than 100, right? But it would have to be shorter than walking around the field, okay? So if we were going to estimate this one, right, if we were to walk, you know, around the field to not interrupt the game, we'd be walking 60 meters down and then another 100 meters across, right? So 60 plus 100 would be 160 meters if I went this way, okay? So this length of the hypotenuse would have to be less than 160, right? But it has to be more than 60 and more than 100. So our estimate would have to be somewhere between 100 and 160, so maybe we would guess somewhere around 120, okay? Now, obviously, estimates are all well and good, but we would like to be able to have actual calculations so that we can be precise, okay? So in order to be able to do those calculations and we're not just left estimating, we use something called the Pythagorean Theorem, okay? And that's the relationship between the sides of a right triangle. So with the Pythagorean Theorem, it states that in any right triangle, the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse, okay? Basically what that's saying is this nice little formula, a squared plus b squared equals c squared, right? So the legs are considered a and b, side length a and side length b are the two legs. C is considered the hypotenuse. So what this is saying, right, the sum of the squares of the legs, so if the legs are a and b, you square those values and then add them, because that's the thing you would do for sum, is add, and then it's equal to the square of the hypotenuse, right? So the two lengths of the legs of the triangle squared will be the same as if you just took the hypotenuse and you squared it as well, Okay, now there's a great little video that I posted with all the material showing you all the proofs of the Pythagorean theorem. Okay, so I'd want you to go and watch that to get a better idea of what's actually happening with how this kind of came about. Okay, if we were in class, we would have done like a demonstration with starbursts and jelly beans and all that kind of stuff, but I can't, you know, assume that you have all the requirements that you need to be able to do that little lab, so unfortunately we're just kind of stuck to a video right now. Okay, but the big thing to remember with your a squared plus b squared equals c squared, always, 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 c needs to be the hypotenuse. The legs can be interchanged, right? It's just whatever the two other legs are, that doesn't matter which one's a and which one's b, but the hypotenuse always has to be the one that's by itself that it's equal to, okay? And again, a, b, and c are just arbitrary. Right? So not every triangle is going to be labeled ABC, right? We could go back to this example with RST, right? At which point we would say, okay, well then it's going to be S squared plus R squared equals T squared. But as long as you've made the one that's by itself the hypotenuse, the formula still works the same, okay? So let's start going through some calculations here, all right? So I'll switch to the video now in a second. You will see the solutions come up in red anyway, but I'm going to still do them on the board to kind of show you where all those values came from, okay? So again, when we're using the Pythagorean theorem to solve for a missing side length, we will eventually have to square root a value, okay? So you will need a calculator that has a square root button on it. If you're using your phones, just tilt your phone sideways and there is a square root button there, and then you can kind of go from there, or you can use your computer or a tablet, or obviously just a scientific calculator with a square root button, okay? Now, sometimes, though, the answer ends up being really nice, and you might actually be able to figure it out in your head, or using your knowledge of perfect squares, you can get the answer right away, okay? So, for instance, in this first one, if we have a right triangle that has leg lengths of 6 centimeters and 8 centimeters, what is the hypotenuse, okay? So we've been given this kind of triangle, right, where this is 6 centimeters here, there's my right angle, and there's 8 centimeters. I've been asked, what is this value right here? Okay, so using Pythagorean theorem, right, this is clearly the hypotenuse because it's directly across from the right angle. These would be my other two legs. So when I set up Pythagorean theorem and it's a squared plus b squared equals c squared, it doesn't matter which one of these is a and which one of these is b. Okay, because when you add things together, it doesn't matter the order you do it, okay? But you just have to make sure that that one by itself is, in fact, the hypotenuse. So why don't we just arbitrarily say, okay, this is side length A here, and this is side length B, which means what we would do is we'd take 6 and we'd square it. So we have 6 squared plus the B value is 8, 8 squared, and that's equal to the hypotenuse squared. So 6 squared is 36. 8 squared is 64, right? Then we can add these two things together. 36 plus 64 is 100. 100 is equal to c squared. So what that's saying is some number squared is equal to 100. And if you kind of have a good knowledge of your perfect squares, you kind of go, oh wait, I know what that is. 10 squared is 100, and you can jump straight to your answer, right? 10 is equal to c, and you know that that's 10 centimeters, right? So just as a quick reminder, a perfect square is a number that when you square root it, you get a nice whole answer, right? So your perfect squares are 1, because 1 times 1 is 1, 4, because 2 times 2 is 4, right? It's the same number multiplied by itself, right? And that the answer is your perfect square. So then if you went 3 times 3 is 9, so 9 is a perfect square, right? Because the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So the next one would be 16, right? Because the square root of 16 is 4. The next one would be 25, because the square root of 25 is 5. The next one, 36, right? And then it's 49, 64, 81, 100, 121. And you just kind of keep going. Okay, but so if the answer ends up being, 4, 9, 16, 25, 36, you may not need the calculator because you know what it is, right? But if not, you can say, well, how do I get rid of this squared value, right? You are undoing the operation. We're solving for an unknown, so c ends up being the square root of 100, okay? And then when you punch that into your calculator, you get that answer there of 10, okay? So that's what we're kind of going to be dealing with here a lot, okay? So let's just kind of work through some other examples now, maybe where we aren't able to just tell what the answer is, but we can, always check for the reasonability of your answer based on that estimating strategy slide that I just discussed, right? So here we have our first example. So a ramp from a walkway to a doorway has a height of 30 centimeters. The length along the ground is 4.5 meters. And the question is asking, calculate the distance a wheelchair travels along the ramp. Write your answer to the nearest hundredth, so that's 2 decimal places of a meter. Okay? So, the first thing we need to look at here, switch back to my video, right? So there's the diagram, right? It's a wheelchair ramp. This height is 30 centimeters. This is 4.5 meters along. I'm being asked, okay, so if the person is going in the wheelchair, I'm just going to try and draw the wheel part, they're going to be going up the ramp. So I would like to figure out what is this distance right here, okay? So I'm essentially looking for the hypotenuse there, right? Because if that's my right angle, that's my hypotenuse. If I label my triangle, right, and I label it A, B, and C, then the hypotenuse will be side length C, right, just like it is in Pythagorean Theorem. Side length B will be down here, and side length A will be up here, okay? So we would kind of think, all right, I'm going to use Pythagorean Theorem to solve for that, and I would do A squared plus B squared is equal to C squared. However, just like when we did all of our calculations with area, you had to make sure that everything was in the same units. Same thing goes for this type of problem. This is in centimeters, this is in meters. I need to make sure that everything is in the same units. So the first thing I'm going to do is convert that 30 centimeters into meters. And I'm going to do that by dividing it by 100, because there's 100 centimeters in a meter, right? Or if we go back to how we used to do this with our unit conversions, start with what you have, multiply by the relationship between what you have and what you want, right? What you want goes on the top. I want meters. What I have is centimeters. And the relationship is there are 100 centimeters in 1 meter. So if you did 30 times 1 divided by 100, you end up getting a value of 0.3 meters. Okay? So then I'm ready to do this. So 30 centimeters is now actually 0.3 meters. All right, so that was our side length A, right, when we labeled it. So that'll go in for A, so 0.3 squared plus B, 4.5 squared, equals C squared that I don't know, right? Again, checking for the reasonability of our answer, we know that our answer should be bigger. It has to be bigger than both of these, right? So it has to be bigger than 4.5 meters, right? We know it has to be bigger than that, but it should be shorter than the 4.5 plus 0.3, right? So it should be somewhere between 4.5 and 4.8. Bless me. Okay, so that's kind of where we should be looking at. We should be getting an answer that's somewhere between 4.5 and 4.8, and if we're not getting an answer there, then we may have made a mistake, okay? So at this point, we do this, we 0.3, we square it. That gives us a value of 0.09. And it's okay that that number is actually smaller when you're squaring it, multiplying it by itself, because when you multiply a number less than 1 by another number less than 1, the number actually gets smaller. Right, because when you do multiplication by fractions, like taking a half of a half, right, you end up getting a quarter, it gets smaller, okay? So then we square 4.5, that's 20.25 equals C squared. Add these two things together, so the 20.25 plus 0.09, and we now have a value of 20.34 is equal to C squared, right? So already we know that this can't be our answer, because our answer, we've already kind of done our estimate. It needs to be somewhere in between 4.5 to 4.8, right? It has to be shorter than the sum of these two, but it has to be bigger than all of them, right? So having an answer of 20.34 makes no sense. So because it's C squared, right, what we do is we square root it. So we do the square root of 20.34. That's what's equal to that hypotenuse value. So the square root of that value is actually 4.51 meters. Okay, so it does fit. It is a little bit bigger than the 4.5, right? And it's definitely less than the 4.8. Okay, and again, the reason that this is only slightly larger than this is because it's not much of a rise, right? If you think about 4.5 meters versus 30 centimeters, like the height of a ruler, we don't have a whole lot of rise happening there, so it's very, very similar to just the length, okay? But there's your first example. Okay. Let's meet again. Example 2. Okay, so in this one, we have that some villages can be accessed by plane only. Right, so we've got these 3 villages listed here, village 1, village 2, and village 3. So the distance going straight from village 1 to village 2 is 42 kilometers. Oh, sorry. The village going from village 2 to village 3 is 18 kilometers, and we can see that there's a right angle that's been formed going from village 2 to village 3. And we're trying to find the distance of the flight from village 1 to village 3. Right, so if we, again, shortest distance from one place to another is always a straight line. If we're flying, we should be able to fly a straight line, right, providing there's no like mountains or anything we need to avoid, okay? So we don't need to worry about rivers that need to be gone around or bogs or anything like that. So what we have is the following diagram. I'm just going to draw on my board so I have it. All right, and we have 42 kilometers here, and we have 18 kilometers here. Okay, so we again are looking for this distance here. So again, if I label my triangle A, B, C, right, and if you always want the C squared to be the hypotenuse, you'll always want to label your right angle as C, if that helps. Okay, so that would mean that the hypotenuse would be side length C, right, going directly across from the right angle. Side length A would be the 42 kilometers here. Side length B would be the 18 kilometers here. All right, so then if you're trying to solve for this, right, the relationship between the 3 sides is going to be found using the Pythagorean theorem. So A squared plus B squared is equal to C squared. These are the same units, so we're okay there. A is 42, so 42 squared plus 18 squared is equal to C squared. So I square each of these values. 42 squared, 1764. 18 squared, 324, equals C squared. So 1764 plus 324 is equal to 2088, is equal to C squared. So again, your last step here is going to have to be square rooting, right? Because again, using our estimation strategies, we know that this value should be bigger than either of these, so it has to be bigger than the 42, right? So it should be somewhere between 42, but less than the sum of them, right? So less than just going over here and then down. And 42 plus 18 is 60. Okay, so our answer should be somewhere between 42 and 60 is a reasonable answer, so clearly this is not our final answer. So the last thing we do is we square root, and the square root of 2088 is equal to 45.7. So 45.7 kilometers, but I think the question asked for the nearest kilometer, so since that's a 0.7, this whole thing would round up to 46 kilometers. Okay, so there we go, and again, it fits with our somewhere between 42 and 60. All right, so there we go. Okay, let's go back. We've got 2 more examples to look at. All right, so here in example 3, we have Jeanette, who needs to clean her eaves troughs, right? So the stuff that's on the top of your roof that might collect leaves or debris throughout the year, right? Blowing wind and all that. She owns a 20-foot ladder. She wants to know how high up the side of her house the ladder will reach if she puts the bottom of the ladder 5 feet from the house. Write your answer to the nearest foot. Okay, so obviously when we put up a ladder against a house, right, so if this is our house, right, with our roof here, right, and these are the eaves troughs that she needs to clean, okay, we are placing a ladder. We don't put the ladder straight up. We put the ladder on the ground and we angle it this way, okay? We know the length of the ladder is 20 feet, right? So from the bottom of the ladder all the way to the top of the ladder, that's 20 feet. we've placed the ladder 5 feet away from the base of the house, right? So this distance here is 5 feet. Houses are typically built straight, so we know that this would be a right angle, right? Your house is not, we're going to assume that this house is not leaning. And we're being asked, how high up the house can this ladder reach if it's a 20-foot ladder and it's being placed 5 feet away? So we're essentially solving for this value here, h, right, the height. So again, we can label this triangle, right, and maybe I'll label this triangle, I don't know, E, F, H. Okay, so again, it doesn't matter which letters we choose as long as they're different, right? So E, F, H. And, right, so that would mean that, again, if this is angle H, this is side length H for the height or the house, right? F, right, or maybe let's rename this. Let's call this L, right? So that when we go across, we get lowercase l for the ladder, right? And maybe we change this again and we call this G, so that when we go directly across, you get lowercase g for the ground, right? You can make it make sense if you want, right? Just however you want, or you can just label it ABC again. It really doesn't matter, right? But it just kind of drives that point home about how we label that triangle, okay? So notice how in this one, we actually have the hypotenuse value, right? So the hypotenuse is given to us, and not in the same way as before, right? It's one of the legs we're looking for. But we can still use that same equation, right? It's that whole a squared plus b squared equals c squared. Now I'm going to redo that, though, with the letters that I've chosen, right? Remember, c just has to be the hypotenuse. So in this case, the hypotenuse is the ladder, so this is L squared. And the legs don't actually matter, right? But I'll call it h squared plus g squared. Okay, so again, these are just placeholders. It doesn't have to be A, B, and C as long as the hypotenuse is that last one that's by itself. Okay, so let's fill in the values that we know and the ones that we don't. So H is a side length I don't know. G I have as 5. And L, the ladder, I have as 20. Right, so let's do what we can here. I can't do anything with this because I don't know what it is, so I'll just leave it alone for now. I can do 5 squared, that's 25. I can do 20 squared, that's 400. And in this case, ultimately, what we're trying to do is get h by itself, right? So right now, h is being squared, and it's having 25 added onto it. So with math, when you're solving something, you're undoing those operations, right? Do the opposite. So if you think about the order, h is being squared, then 25 is being added onto it. Let's work backwards. So if I want to get rid of adding 25, I subtract 25 from both sides. Right, so then that would be 0, and I'm just left with h squared, and 400 minus 25 is 375. Right, h is still being squared, so to undo a squaring, I square root. So h is the square root of 375, and h is now 19.4 feet. Okay, and again, that makes sense because this had to be our biggest value, right? The hypotenuse is the longest side. So the value that we should get for either of the legs has to be less than 20. If we got a number bigger than 20, we know that it's wrong. Okay, so in this case, the ladder can reach a height of 19.4 feet up the house with a 20-foot ladder placed 5 feet away. Okay. So again, their solutions are there. This one was one from the textbook. So what you're seeing there is, again, that same diagram that I just drew. They've gone with the convention of just labeling it A, B, and C. Okay, when they do the proofs and stuff of the Pythagorean Theorem, when they talk about like the squares, they actually draw a square with that side length on each of the sides to kind of show you that this area would be 25 and this area would be 400, and you need these two things to add, but you're getting the same equations here. You don't have to do this part, right? So you're getting the same thing. They were solving for A instead of for H. Again, it doesn't matter. It's just a letter, okay? I guess it did ask for just rounding to the nearest foot, so our 19.4, right, would have rounded down, okay? All right, last example. So in this one, a 60-inch TV measures 52 inches along the top of the screen. What is the height of the screen? Okay, so when they measure televisions and they talk about it being a 60-inch TV, they're talking about the diagonal, right, from corner to corner. So what you're seeing in this diagram here is you've got this obvious rectangular television, where it's 52 inches across the top, and the 60 inches is the distance going from one corner down to the bottom. And we're being asked, what is the height of the screen? Okay, round your answer to the nearest inch. So if we do that, right, so I've just basically redrawn that, where you've got 52 inches and then the 60 inches going across. Now again, because this is a rectangle, rectangles have right angles in all of their spots, so what you end up getting is this nice triangle, and if you want, you can just erase the rest of it, so you can just see the triangle part, right, and there's your right triangle, 52, 60, and then your right angle, right, so again, I can relabel this A, B, C here, right, so again, I've chosen it in such a way that the hypotenuse, right, the side directly across from the right angle, would be side length C. Side length B is the height in which we're actually trying to find that value, and side length A is up here. Okay, so if we did that, we can set up A squared plus B squared is equal to C squared. Okay, fill in the values that we have. A was the 52, so 52 squared plus B, we don't know it, so we're trying to find, is equal to C squared. C was 60. So 60 squared. We can square all those values. 52 squared, 2,704, plus b squared is equal to 60 squared, 3,600. Okay, so again, in this case, we're trying to get the b squared by itself, right? So b squared is being added to 2,704. So I'm going to subtract 2,704 from both sides. And we get that b squared, right, so that would cancel out and be 0, and when I do that subtraction, I get 896, okay? So obviously I know that can't be my answer, because this has to be less than 60, so because it was b squared, in order to get this as an answer, right, so if I had b squared is equal to 896, to get b by itself, I square root the other value, right, so it's like you're square rooting both sides, that cancels, leaving just b on its own, and then if you take the square root of 896, you get that b is equal to 29.93, and it said round to the nearest inch, so b is pretty much 30 inches. Right, so the height of our TV would be 30 inches there. Okay, so you can use the Pythagorean theorem to find missing side lengths. If it's the hypotenuse, right, you don't have to do any rearranging of the equation, it's just square, square, add, square root, and you're done. If you're trying to find a leg length instead, right, square, subtract, square root. Okay, so there's a little bit more to it. Okay, so that's it. You've got some examples, and then you've got some independent practice to try, right? The worksheet's there on Google Classroom. I'll put the answer key up as well, so that way, as you're going through, if you're getting stuck or you want to see, well, did I do this right? You can check your answers and see, you know, am I on the right track here, and go from there. Okay, and then we'll continue with Pythagorean theorem on the next one, looking mainly at just applications, right? So different type of workplace scenarios that would involve Pythagorean theorem. Okay, and that'll be the focus of our next lesson. That's it.